Okay, guys and girls, ladies and gentlemen, welcome back to another episode of the chemistry lessons. Now, I just want to make clear that I am not following the order that in which the book is in, because it is in my opinion that the order of the book is absolutely ridiculous. And so because of this, I'm doing it in a completely different order, but it will cover all of the content that you need to know. So today what we're going to be looking at is the history of the periodic table. So the history of the periodic table, and the reason why I decided to place it after the history of the atom is because there's a name that you will be familiar with, and so it kind of links with that. So John Dalton was one of the first people to kind of think about ordering the elements in terms of their atomic weight. Okay, so he was the first person to kind of think of that idea. Now, he did this by carrying out quite a few experiments, and he would determine the weight of each element that he experimented with. However, the majority were wrong. Okay, so he ended up calculating quite a lot of the atomic weights of different elements incorrectly. Now I'm going to show you what his periodic table looked like. Okay, so here is John Dalton's periodic table, and as you can see, he's got hydrogen and then another element which was probably a different name for the element at the time. He's got carbon, oxygen, phosphorus, sulfur, and all of these, and as you can see, the smallest number is hydrogen, and then it increases in its weight number. So if you look at hydrogen is the smallest number, then it gets bigger and bigger and bigger and bigger as you're going down. So this is just to emphasize and to show you that it was John Dalton's idea to order elements in terms of their increasing size, however, increasing atomic weight. However, if you do look at the numbers, the vast majority of them are wrong, but you can't knock him for that because he used what he had at his time. The level of accuracy wasn't going to be there. This was, remember, the 1800s, so you got to give him some credit for at least attempting. And remember, guys, John Dalton believed that the atom was the simplest part of any element and that they were indivisible, and as we looked at video 2a, we know that he was wrong about that, because of course it's made of protons, electrons, neutrons and all that stuff. So what's the next stage of the development of the periodic table? Right, so what you've got to remember is that the first person to develop this the ordering of elements by their atomic weight was John Dalton, right? Then there was another John who kind of took that idea but did it a little bit different. This guy's name was John Newland. So the way to remember who came first is in the alphabet, D comes before N. So John Dalton had the simple idea, and John Newland had a more complicated idea which made more sense at the time, and his idea was actually called the octaves, right? And it's taken from the idea of piano keys. Okay, so and here is his periodic table. Let me just show you it. Here's his periodic table. So what I want you guys to notice about John Newland's arrangement of the periodic table is that the atomic weight increases as you go down the group. Okay, so what you've got is it starts off from 1, then 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, etc. So the atomic weight is increasing. So he's kind of used John Dalton's idea, and I'll just put it at the top just so that you guys remember that this is John Newland's periodic table, right? And what he believed is that if you take an element, the first element, and you count, now the word oct means 8, like octagon, right? So if you take the first one and then count up 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th one. And what he noticed is that hydrogen, the first one, will have the same properties or similar properties as the 8th one. So if you take this one now and you count 8, you'll end up here, and this one will have similar properties to the one above it. So this one, let's say you make this one number 1, you go 1, 2, 3, 4, 5, 6, 7, 8. So this one will be the 8th one, and fluorine will have similar properties to sodium. Now this was a good observation at the time. However, the pattern only works up to calcium, right? It doesn't work any further than calcium. So that was one of the weaknesses of John Newland's periodic table. Now the last scientist and the last periodic table was a scientist called Mendeleev. Okay, so Mendeleev, and his first name was Dmitri. Now here is Mendeleev's periodic table. Now straight away it's kind of looking like the modern periodic table. You can see that the atomic weights or the mass number, they're becoming very similar to what we have today. So take for example carbon. Here is carbon. Its atomic weight, or its mass number as we call it nowadays, is 12, and that's correct. Nitrogen is 14, that's correct. Oxygen is 16. So straight away you can see that there was much more discovery and much more progress made from when we started in the 1800s with John Dalton. So it's come a long way already. The other thing that it shares similarity with is it's got group numbers. So if you look here, it's arranged in group 1, group 2, group 3, group 4, 5, 6, 7, and group 8. And so he's arranged them once again. If you look at the numbering, I just want to highlight the numbering. I'll just get rid of all of this. It's increasing in size as we move along. So it's 1, 2, then 9 is the next biggest, 11, 12, 14, 16, 19, etc, etc. So if you go across, then that's what you get. Also, if you look here on this side, he's also made some periods. So we've got the groups which go down, remember, and periods which go across. So it's already beginning to look like the modern periodic table, but it's not exactly the modern periodic table, and I'll tell you why. Look at this here, group 8, right? It's got quite a few transition metals, right? A lot of these are transition metals, whereas nowadays we've got, instead of transition metals, we've got noble gases. And if you do compare like where the transition metals are found nowadays in a modern periodic table, they're found in the middle block, right? So they're not in group 8, they're in the middle block. What else? So you've got in group 7, you have some transition metals as well. This is just so that it kept in order of atomic size, atomic weight. Now he did also try to group them with where there were similar properties, okay, but sometimes he just had to clump them together to keep it in order of his size. However, what was amazing about Mendeleev's periodic table was this here. Look at this. He's left gaps, and so he predicted that these would be found, right? So he said, you know what, I don't know what there is, but if this pattern is to be true, then there must be elements that are not discovered yet that will have this weight, that will have these properties, because within this group there are these properties, and so he's left a gap because he's predicted them, and a lot of them were discovered later on, which is really, really amazing. And then finally, it's the modern periodic table, which I covered in video 1. So if you do want to look back at video 1 just to look at the modern periodic table, you can do. But with chemistry, we are going to constantly be looking back at the periodic table. So you can look back, but we're going to be covering it at loads and loads of different points.